Good day, students. Mr. Deegan here with another edition of VidNotes videos. This time we're headed to Unit 4 for the era of revolutions. Era meaning time period, revolution meaning a time of radical change. And in Lesson 1, we're going to be dealing with the scientific revolution, a time of change in science and technology and the way of looking at the world. Before the scientific revolution, much of the world looked at the universe like this. The Earth was at the center of it all, and there were planets in the distant sky, and then you had angels and demonic beings, and then the sun was somewhere else in the sky, but the Earth was at the center of the universe in this ancient way of thinking. However, during the scientific revolution, the idea of the heliocentric theory, the idea of the sun at the center of the universe, takes hold. The question that will guide us this lesson is, what is the best way to challenge authority? Many scientists changed the way people thought about the universe. And they did so not by fighting, not by physical violence and war. That's one way to challenge authority. But rather, scientists used ideas to challenge authority, especially the authority of the Catholic Church, who promoted the idea of the Earth being at the center of the universe. First, when was the scientific revolution? It was from 1500 to about the year 1700. And what else is going on during the scientific revolution? While scientists are discovering, you have the Renaissance, the Italian Renaissance of Mona Lisa, Leonardo da Vinci, and other artwork and artists. You also have the Protestant Reformation, Martin Luther, and other reformers are changing the Catholic Church. You also have the Age of Exploration, the Columbian Exchange, and European explorers are expanding their view on the world. Here are the two models of the solar system I was just talking about. The geocentric theory, geo, Greek for earth, meaning that the earth is at the center of the universe, versus the heliocentric theory, helio, Greek for sun. The sun is at the center of the universe in this theory. These are two dueling models for how we look at the universe. And the controversy started with the church using Bible passages from the Christian Bible to say that the earth is at the center. This is one from the book of Psalms. It says, "The Lord reigns. He is clothed with majesty. The Lord is clothed with strength. The world is also established that it cannot be moved." The church took this literally to mean that the earth is not movable. Ptolemy was an astronomer from ancient Greece being about 100 CE after the birth of Christ, and he taught geocentrism. And his science was accepted by the Roman Catholic Church. However, many years later, Nicolaus Copernicus of Poland, you see here with his scientific instruments, he is a mathematician and scholar who creates a scientific formula to prove the heliocentric theory and to disprove Ptolemy and the Roman Catholic Church. What was the reaction to Nicolaus Copernicus's work? Well, there was only mild controversy. He himself was a Catholic, and the church was light on him. Martin Luther said he was a fool who went against the Holy Writ. So although he had some verbal abuse against him, he was not punished in any real way. The Catholic Church largely stays silent. After Copernicus, you have Johannes Kepler of Germany. Here he is with a scientific instrument, and he uses data from other scientists to study the laws of planetary motion. and he calculates that the planets orbit in an elliptical shape in the universe, not a perfect circle. And he also researches to support Copernicus's heliocentric theory. So here is his calculations on an elliptical orbit in planetary motion. Next, we have Galileo Galilei from Italy. Here he is in his older years. He builds a powerful new telescope. This telescope was so powerful that it could see more of the solar system than anyone had ever had before. With his heavy-duty telescope, Galileo is able to observe Jupiter's moons. He's able to observe the detailed craters on the Earth's moon, and he is able to observe spots on the sun for the first time. And he is an avid, enthusiastic defender of the heliocentric theory, first calculated by Copernicus. What was the reaction to Galileo's work? Although he didn't come up with the heliocentric theory, he is punished by the Catholic Church for his views. The Catholic Inquisition, that period of time when the Church punishes heretics, accuses this man, Galileo, of heresy. And in February of 1616, the leader of the Church visits Galileo's house with a note. And the note says that Galileo needs to abandon completely the opinion that the earth moves and henceforth no longer teach or defend this opinion, orally or written. Well, later on, Galileo, about 17 years later, in June of 1633, he is brought to the Inquisition court in Rome. He apparently did not follow this note given to him. Here is a painting that shows Galileo front and center. He is in front of the Catholic Inquisition judges, and he, in this trial in 1633, is forced to recant or to take back his views on heliocentrism and was found guilty of heresy. Because of that, his punishment is that he is placed on house arrest by church leaders until his death in 1642. He is confined to his house. What would you have done? Would you have taken back everything that you have worked so hard for? From Italy to England, and an English doctor named William Harvey. Here he is. And here is what he did. He studied blood circulation in the human body, and he was one of the first to demonstrate how the heart pumps blood to the rest of the body. And how did he do that? He had an unusual way of researching. He researched on the wounded and dead bodies on battlefields. So William Harvey was an unusual doctor, but he helps us better understand blood circulation. Another English fellow, this man was knighted for his work in mathematics and physics. It's Sir Isaac Newton. And here you see him, an actor version of him with a bruised forehead and an apple. This was a complete myth. He did not sit under an apple tree and have an apple clunk him on the head. There was no aha moment of gravity. Instead, he devised a formula for the laws of gravity. And he realized that gravity is what anchors the solar system together, and it makes things fall to Earth. His research is the basis for modern physics. What is the overall significance and importance of the scientific revolution? 3 things. First, there was an emphasis on reason and the systematic observation of nature. Just like in the Renaissance with humanism, the scientific revolution de-emphasized religion and emphasized the idea of people thinking for themselves about what was around them. The scientific revolution also saw the formulation of the scientific method. And here it is to the right. You do this in science class. You make an observation, you ask a question, you make a hypothesis about your question, and then you perform some type of scientific experiment. After this experiment, you ask, did it work? Then you develop a theory, and then you do more experiments. This scientific method was created during the scientific revolution. And the scientific revolution was also important because, thirdly, there was an expansion of scientific knowledge, an explosion that became the basis for further research. We're almost done with lesson 1, ladies and gentlemen. We have but our summary questions left. So please pause the video and do your summary questions now. And a preview, next lesson, lesson 2, we will be talking about absolute monarchs in Europe and Russia. How do these monarchs completely control their countries and empires? We'll talk about that next time. Until then, this is Mr. Deegan signing off.